In this video, I'm going to cover 4 types of firewalls. The first one is the packet filtering firewall. The packet filtering firewall is the most basic firewall. In the packet filtering firewall, each incoming packet is examined and only those packets that match the criteria you set are allowed to pass through. Many operating systems such as Windows and many Linux distributions include basic packet filtering software with the operating systems. Packet filtering firewalls are also referred to as screening firewalls. They can filter packets based on packet size, protocol used, source IP address, and many other parameters. Some routers offer this type of firewall protection in addition to the normal routing functions. Packet filtering firewalls work by examining a packet's source address, destination address, source port, destination port, and the protocol type. Based on these factors and the rules that a firewall has been configured with, they either allow or deny passage to the packet. Well, these firewalls are very easy to configure and also are inexpensive. There are a few disadvantages of the packet filtering firewalls. One disadvantage is that they do not actually examine the packet or compare it to the previous packets. Therefore, they are quite susceptible to either ping flood or SYN flood. They also do not offer any user authentication. Because this type of firewall looks only at the packet header for the information, it has no information about the packet contents. It also does not track packets, so it has no information about the preceding packets. Therefore, if thousands of packets came from the same IP address in a short period of time, a host would not notice that this pattern is unusual. Such a pattern often indicates that the IP address is in question and is attempting to perform a DOS attack on the network. Next is the circuit level gateway firewall. Circuit level gateway firewalls are similar to application gateways, but are more secure and generally implemented on the high-end equipment. These type of firewalls also employ user authentication, but they do so in the earlier process. With an application gateway, first the client application is checked to see if the access should be granted, and then the user is authenticated. With circuit level gateways, authenticating the user is the first step. The user's login ID and the password are checked, and the user is granted access before the connection to the router is established. This means that each individual, either by username or IP address, must be verified before any further communication can take place. Once this verification takes place and the connection between the source and destination is established, the firewall simply passes bytes between the systems. A virtual circuit exists between the internal client and the proxy server. Internal requests go through this circuit to the proxy server, and the proxy server delivers those requests to the internet after changing the IP addresses. External users only see the IP address of the proxy server. Responses are then received by the proxy server and sent back through the circuit to the client. It is this virtual circuit that makes the circuit level gateway secure. The private secure connection between the client application and the firewall is a more secure solution than some other options, such as simple packet filtering firewall and the application gateway. Where traffic is allowed through external systems, never see the internal systems. Next is the application level gateway. An application level gateway is a program that runs on a firewall. This type of firewall derives its name from the fact that it works by negotiating with various types of applications to allow their traffic to pass through the firewall. In networking terminology, negotiation is a term used to refer to the process of authentication and verification. In other words, rather than looking at the protocol and port the packet is using, an application gateway will examine the client application and server-side application to which it is trying to connect. It will then determine if that particular client application's traffic is permitted through the firewall. This is significantly different from packet filtering firewall, which examines that the packets and has no knowledge of what sort of application is sent through them. Application gateways enable the administrator to allow access to only to a certain specific type of applications, such as web browsers or FTP clients. When a client program, such as a web browser, establishes a connection to a destination service, such a web server, it connects to an application gateway or proxy. The client then negotiates with the proxy server in order to gain access to the destination service. In effect, proxy establishes the connection with the destination behind the firewall and acts on the behalf of the client, hiding and protecting individual computers on the network behind the firewall. This process actually creates two connections. There is one connection between the client and the proxy server, and another connection between the proxy server and the destination. Once a connection is established, the application gateway makes all decisions about which packets to forward. Since all communication is conducted through the proxy server, computers behind the firewall are protected. The last one is the stateful packet inspection. The stateful inspection firewall is an improvement on the basic packet filtering. This type of firewall will examine each packet, denying or permitting access based on not only on the examination of the current packet, but also on the data derived from previous packets in the conversation. This means that firewall is aware of the context in which a specific packet was sent. This makes these firewalls far less susceptible to ping floods and the SYN floods, as well as being less susceptible to spoofing. These firewalls are less susceptible to these attacks because of following reasons. They can tell whether the packet is a part of abnormally large stream of packets from a particular IP address, thus indicating a possible DOS attack in progress. They can tell whether the packet has a source IP address that appears to come from inside the firewall, thus indicating IP spoofing is in progress. They can also look at the actual contents of the packet, allowing for some very advanced filtering capabilities. Most quality firewalls today use the stateful inspection method. When possible, this is the recommended type of firewall for most of the systems. In fact, most home routers have the option of using stateful inspection firewall. The name stateful packet inspection derives from the fact that in addition to examining the packet, the firewall is examining the packet's state in relationship to the entire IP conversation. This means the firewall can enter, that is, refer to those preceding packets as well as those packets contains source and destination. As you might suspect, the stateful inspection firewalls are becoming quite common. Limitations of firewall. As shown on the screen, a firewall cannot prevent users or attackers with modems from dialing into or out of the internal network, thus bypassing the firewall and its protection completely. Firewalls cannot enforce your password policy or prevent misuse of passwords. Your password policy is crucial in this area because it outlines acceptable conducts and sets ramifications of non-compliance. Firewalls are ineffective against non-technical security risks such as social engineering. Firewalls cannot stop internal users from accessing websites with malicious code, making user education critical. Also, firewalls cannot protect you from poor decisions. Firewalls cannot protect you when your security policy is too weak.